Lesson 4 and 5, does the mass change? Our objective today is that students will observe physical changes in order to determine if a change in mass has occurred. Now, previously, you should have made a prediction based on 4 demonstrations what would happen to the mass of a substance. The first demonstration was which has more mass, a tightly wadded ball of steel wool or the same steel wool stretched and pulled apart. If you had not made these predictions yet, pause this video, go back to the page Lesson 4 Does the Mass Change, and read each demonstration and make a prediction on what you think will happen to the mass. Moving on to Lesson 5, we are actually going to put these demonstrations to the test. So, demonstration 1 is which has more mass, a tightly wadded ball of steel wool or the same steel wool stretched and pulled apart. I have my scale handy and I'm going to ball up my steel wool as tight as I can possibly get it. Make it super dense, super tightly compacted, and put it on the scale. I am finding a mass of 2.8 grams. I'll remove the steel wool from the scale, and I'm actually going to pull it apart on top of the scale in case any pieces start to fall off as I'm pulling it apart. But now I will pull apart the steel wool, make it super stretched out, taking up more space, stringy. What do you think will have happened? Will the mass go down? Will the mass go up? Or will the mass stay the same? Placing the same steel wool back on the scale. We have a mass of 2.7 grams. Now, this is a perfect example of human error. I lost quite a few pieces of steel wool when I was pulling it apart. You can kind of see them all as I sweep them together here that have fallen off the scale. And I think that they, if I could have gotten them all back together, would account for that 0.1 gram. Ideally, we would not have found a mass change from the same exact piece of material in 2 different shapes.